Hi all, and welcome to a quick demo slash walkthrough of our masking, plugin, and enclosure module within NTOP. The purpose of this module is to generate masks, plugs, or enclosures for remanufacturing or jigging or fixturing. So to start off, we import a part, and we can use our import part block and simply locate the file in this path variable here. The initial workflow we're going to go through is to generate surface plugs. This workflow is meant for plugging specifically cylindrical holes. So in this case, the first input is the part. We can drag and drop the part variable into our input. And the next is a list of holes we would like to plug. So to select these, I'm going to make a list equal to the number of hole plugs I would like to make. And I'm just going to go ahead and select those off the CAD object. So I'll click the select object here and select these 4 cylindrical holes. Once I've selected those holes, the last CAD feature input is the flush surface to those holes. In this case, that would be this surface here. So I'm going to go ahead and click the select input and select this guy. Now you'll notice there are other parameters such as the depth, the thickness, radial offset, clearance, taper angle, and resolution. These input their parameters and how you should adjust them depending on what you would like to achieve is available in the course. And I'll let you guys play around in the course to see what each of the inputs do. You'll see here, and let me just provide a section cut of the part. The plugs were generated, and these ones have a 5-degree taper, I believe, for an interference fit, as well as some additional clearance at the edges just in case. Applying this cap grip as well will split this thickness into 2 and have the ability to easily remove the caps from the part. Awesome. Now the second part of this module of 3 is to create surface masks. Surface masks are used to create flat-ish or contoured masks, or what we used to call them stickers. Essentially, if you're using some flexible resin or printer and you want to cover a surface or apply adhesive to stick to the surface, you can do that using our surface mask. So similar to the first input of the first workflow, we are going to drag and drop the part we're looking to mask as an input here. And then in this case, we're going to specify which surfaces we would like to generate the mask for. These do have to be surfaces that are touching each other for this to work. And in this case, I'll create a surface mask for these surfaces here. And you'll notice a surface mask has run, and we now have this part. Now you can control the thickness. This looks awfully thick, so we could lower the thickness as well as do some other operations such as increase a clearance, a resolution pertaining to mesh and feature size that you'd like to capture, and as well as an overhang for surfaces on the edge, and that would generate an overhang along this surface here. The next module we'll explore is creating surface enclosures. And surface enclosures are meant to fill more than just holes or plugs, essentially an entire entrance to a part. So in this case, you'll notice here this surface we could enclose to prevent any, say, paint during a painting job or similar, or to protect this surface completely during a sandblasting or other type of operation. So in order to create the surface enclosure, the first thing we're going to do, similar to the first 2 modules, is drag and drop our part into the masking part input, and then the surface we would like to enclose. So again, in this case, it would be this surface here. Awesome, and you can see the surface enclosure has run, and we'll do a section cut quickly here just to show you what it looks like on the inside. You'll notice, similar to the plugs, there is a taper as well, and in this case we have a clearance that can be adjusted. Obviously, if you want an interference fit, you could even enter a negative clearance and that taper to really push it in there and have it fit nicely. There is a second more commonly used option for this, and that is to use the same enclosure but generate a lip on the outside as well. So I'll demonstrate that now very quickly. To change that, we are going to change from the enclosure type from inside only to conformal. And for this purpose, I'll also remove the taper angle so you can see what that looks like. Awesome, the enclosure has been made, and you can see when I do a section cut here that the enclosure now includes the outside as well, and is going to prevent anything from getting in there during remanufacturing methods. You'll notice there is still this clearance that I can reduce if I want an interference fit. Awesome. These modules all produce mesh files, so they are already meshed and exportable as either STL, OBJ, or 3MF. And the way we are going to do that is by dragging and dropping any of them into the mesh export block available at the bottom here. And then we just have to specify the part name and the path where we would like to save the file, and that will export automatically. There are additional beta features available at the bottom for turning these mesh parts into CAD parts and export as step files or Parasolid files. More info of this is available in the course, so please check it out. Thanks very much for watching. Hopefully this helps. Feel free to reach out to N-Topology if you have any questions about using the module. Thank you.